reaches the nephridiopore. Okay? So this long tube that waves back and forth across itself and eventually opens up here at the nephridiopore, that's kind of the functional unit of the excretory system. Just like the flame bulbs, those protonephridia were the functional units of the planarian, this, it constitutes the functional unit of the earthworms. Protonephridium early, meta, in this case, think higher. It's a more complex version of the protonephridium. It's a metanephridium that's found in the earthworms. Okay? All right, so works just like the other system does. We bring material in through the nephrostome. That's the opening into the metanephridium. Material comes through the nephrostome. Okay? That means the nephrostome is the filter. That means that this fluid in this compartment, once it enters into this metanephridium, is now filtrate. The filtrate is moved through the tubule, right, and eventually is going to exit out of the body. On its way through, notice that by folding this thing back and forth across itself, what I've done is increase the surface area for reabsorption and secretion. Because the more transport epithelium I have here, the more secreting and reabsorption I can actually do. Does that make sense? The more of this I can do. So that's why it's probably folded over back and forth across itself, is to take advantage of extra surface area for the metanephridium function. Right? The filtrate has now entered in through the nephrostome, and now all along here, where the capillaries are connected, I'm going to do reabsorption. Pull stuff back out of the filtrate, grab some calcium, some glucose, anything else I want, and then bigger molecules I'm trying to get rid of, secretion into the metanephridium, and then once I'm done with all that, it exits the body of the earthworm through the nephridiopore. Okay? Right. You get this idea? It's kind of a same basic system, right? Same basic system with those four pieces to it. An opening at one end, an opening at the other end. This time we've convoluted the tube, folded it back and forth across itself to increase the amount of reabsorption and secretion that we can accomplish. Okay? All right, let's do one more on our way to the most complex one. This particular one is in insects, and this one is not called an nephridium, it's called a Malpighian tubules. Okay? I think it's named after Malpighi or Malpighium or Malpighi or whatever his name is. All right, the Malpighian tubules are these extensions off of the digestive system. In the insects, we don't have a separate excretory and a separate digestive system. They're actually functioning together. So these extensions off of the digestive system between the stomach and the intestine, these outpocketings are called Malpighian tubules. They're basically epithelium, right? So what I'm going to do is have this epithelium take material out of the hemolymph. I don't have a closed circulatory system in insects, it's open, which means the hemolymph is all over the place. It's not contained within vessels. So I'm just going to start transporting material into that Malpighian tubule, move that material in, and as it comes in, it gets dumped into the digestive system. So the transport epithelium in this case is the filter, which means the material that's in these tubules coming in would be filtrate. As soon as this filtrate joins the material in the digestive system, it's all mixed together, so we're